Good day, everyone. The theme of our researches is special ultrasonic cleaning process control based on its current state evaluation. Authors are Vladimir Morkun and Olga Kravchenko. The quality and reliability of the products are directly dependent on the degree of purity. So there are many different cleaning methods used in certain industries. This is a combination of various chemical solvents, manual or mechanical cleaning, as well as ultrasonic cleaning, which eliminated the disadvantages inherent in other methods, such as environmental pollution. Ultrasonic cleaning is one of the most effective in terms of quality and cost. Purification occurs due to the combined action of various nonlinear effects that occur in the liquid under the action of powerful ultrasonic vibration. These effects are cavitation, acoustic currents, and sound pressure. The main physical phenomenon that provides ultrasonic cleaning is ultrasonic cavitation, the implosion of bubbles that occur under the action of changes in fluid pressure during sonication. This is the release of energy which separated the dirt from the body. Cavitation in the ultrasonic bath has a zonal distribution, so the cleaning efficiency is affected not only by the parameters of ultrasound, but also the size of the bath, the location of the emitters. The distribution of cavitation is also greatly influenced by the frequency of ultrasound and other parameters, such as fluid temperature, ultrasound intensity, oxygen content. The large numbers of interrelated parameters that affect the ultrasonic cleaning process complicate the process of forming a control based on standard methods. One of approaches for increasing the energy efficiency of ultrasonic cleaning is to improve the methods of controlling this process. Usually the ultrasonic cleaning process controlled by time factors with expert evolution. But there are new, more intelligent ways to control of ultrasonic cleaning. Thus, Durand factor proposed to use the evaluation of the process by the physical properties of the cleaning fluid, conductivity and turbidity. Such approaches increase the efficiency of ultrasonic cleaning but ignore the real state of the cleaning body, forming a control based on indirect evaluation. More flexible is the formation of assessment based on machine learning. In this way, the condition of treatment facility part of the pipe was assessed by applying a neural network to the received ultrasound responses. Therefore, it is necessary to develop an evaluation methodology that will allow you to form a control based on the state of the treatment plant of any configuration. For greater efficiency, the control of the ultrasonic cleaning process should take into account its spatial distribution and the actual state of the cleaning body. The spatial distribution of ultrasonic cleaning process is caused by spatial distribution of cavitation, uneven pollution, and uneven cleaning of the body. To avoid this, one should use an algorithm controlling ultrasonic cleaning which will consider contamination of a body in its separate areas. It is suggested assessing these conditions through analyzing ultrasonic reflection in the bath, as ultrasonic measurements provide high quality and fast evaluation of space distributed parameters. Ultrasonic non-destructive evaluation is widely used to quantify the mechanical and structural properties of the body. It has established itself well in many industries and continues to expand its application. Existing studies indicate the feasibility of using to determine the degree of heterogeneity of the mechanical properties of the body, coefficients of nonlinearity of the second and third orders. Our method of evaluation current state of ultrasonic cleaning based on the nonlinearity coefficients and the times of receptor the threshold value of the signal for the current and path measurements. To determine the influence of the features of the body configuration on the time of receipt of the threshold value and the nonlinearity coefficient of the second and third orders. Modeling was performed for different shapes of the body, and the corresponding values were calculated. The following were chosen as different shapes of areas: the sector of a circle, the sector of asteroids, and the sector of a circle and asteroids with holes. Ultrasonic responses were recorded for the body of each configuration and with different thickness of contamination. These responses were processed using a fast Fourier transform and obtained values of the largest three amplitudes. The general nature of the changes is uneven. Reduction coefficient beta 2 occurs when a layer of pollution below a certain level, and the increase can be observed for certain geometric shape when the layer of pollution reduced, but overall remains high. The nonlinearity coefficient of the third order is even more dependent on the geometry of the body and does not show patterns in the process of ultrasonic cleaning. Therefore, the decision was limited to the analysis of only the second-order coefficient. An important factor that has a stable behavior and allows you to assess the course of the process of ultrasonic cleaning is the time after which the threshold value of the signal. In slide shows that the change in time occurs almost linearly with a constant increase. For optimal redistribution of the intensity of each emitter in the ultrasonic burst, it is proposed to use a 3D phase interval control type 2, which is essentially designed for spatially distributed process with complex expert evaluation of input parameters. The structure of the controller is similar to basic one, with standard operation of phasification, the phasor logic output, and dephasification. Yet, availability of an additional space coordinate and intervals of the membership function call for their expansion. Given that the current value of the signal received by the sensor is most affected by the state of the immediate environment, the following type was chosen for the membership function, as you can see on slide. That is a special radial normalized coordinate. X is the input value. Membership function has its maximum on the position of the emitter and according to the linguistic mark. On the slide you can see diagram of the upper and lower membership function for the mean positive mark. For the output z equals 0.2. For the output, the membership function is defined in the trapezoid triangle form, as is shown on slide. The membership function is 2D. A special impact is taken into account in phasification of the input, while the output value is calculated depending on its space location. To confirm the effectiveness of the newly developed method for evaluating the course of the ultrasonic cleaning process, a complete modeling of the process was performed using a 3D phase interval controller. The location of the contaminated body for emitters and for sensors was specific. The figure shows working emitters in the form of concentric circles. Color saturation is directly proportional to the radiation intensity. Ellipses and the boundaries of the area indicate the location of the sensors. This modeling shows that in each cycle, the maximum power factor of the emitter reaches closer to the contamination. At the same time, there is a constant decrease in the modulus of the input vectors x1 and x2. In this work, a method of evaluating the course of the process of ultrasonic cleaning by ultrasonic response was formed. To determine it, the purification of bodies of different configuration was modeled and the analysis of the received signal was performed. It was decided to limit the time of receipt of the signal threshold value and the nonlinearity coefficient of the second order to determine the assessment of the cost of ultrasonic cleaning process. The relative changes of these values became the input parameters for the 3D phase interval controller, which performs specially distributed control of the ultrasonic cleaning process. Energy savings using the established estimation technique and 3D phase interval controller amounted to about 35% compared to traditional control, which is limited to time only.